Welcome to the X-2 program overview portion of this DVD. Throughout the production of this DVD package, we've uncovered footage from many of the individual X-2 flights. But after our research was completed, though, we were left with an assortment of footage that we could not tie to any particular flight in the X-2 program. Rather than just toss these bits of film aside, that footage has been assembled here into a hypothetical composite X-2 flight, and will also serve as an appropriate background for a brief overview of the X-2 program. The X-2 was the immediate successor to the Bell X-1, which is very well known for becoming the first supersonic aircraft in 1947. Like the X-1, the X-2 was also a rocket-powered aircraft and was designed to be launched from a modified B-50 bomber. Development of the X-2 began in 1945 as a joint project between the United States Air Force, at the time the Army Air Corps, the National Advisory Council on Aeronautics, and the Bell Aircraft Corporation. The primary goal of the program was to investigate the effects of aerodynamic heating on high-speed aircraft and to explore the stability and control effectiveness of aircraft at high speeds and altitudes. The X-2 was originally conceived as simply a swept-wing variant of the X-1, but significant design changes were eventually made, and it resulted in a dramatically different aircraft. Some consideration was even given to giving the aircraft a variable sweep capability, but the complexity of that challenge led engineers to quickly dismiss that idea. The design was refined by the National Advisory Council on Aeronautics using subscale models of the aircraft in wind tunnels and on rocket-propelled boosters that were flown at Wallops Island in Virginia, and a modified Bell P-39 was also used to investigate swept-wing flight. Two airframes were constructed as part of the X-2 program, and you'll see both of them throughout the course of this DVD package, tail numbers 6674 and 6675. Although it was completed first, the first flight of 6674 was delayed due to development difficulties with that aircraft's Curtiss-Wright XLR-25 rocket engine. Construction of both aircraft was of stainless steel and K-Monel, which was a copper-nickel alloy. Instead of an ejection seat, which at the time was still very new, the X-2 was equipped with a nose section or escape capsule that could be jettisoned. In the event of an emergency, the pilot could release the nose section from the rest of the aircraft. That nose section would stabilize under a parachute, and then the pilot could release the seat back, jump out of the nose section, and then deploy his own escape or safety parachute. The X-2 program had an unusually long development cycle from initiation until the first flight. The first aircraft that was ready to fly, 6675, was finally delivered to Edwards Air Force Base on April 22, 1952. This was almost 7 years after the project was initialized. The initial glide flight occurred on June 27, 1952, and was piloted by Skip Ziegler, who was a Bell Aircraft Company corporate pilot. Significant damage occurred on the landing. It required extensive repairs, and the aircraft had to be ferried back to Bell's New York factory for repairs. That particular aircraft was destroyed over Lake Ontario on a captive test flight on May 12, 1953. This unfortunately resulted in the loss of Skip Ziegler and another Bell aircraft crew member. Years later, it was learned that a gasket material that was used on high-performance rocket aircraft at the time, called Ulmer leather, would become dangerously unstable over time as a result of exposure to liquid oxygen and become combustible. Another casualty of that disastrous flight was the carrier aircraft, which was damaged beyond any reasonable repair. It was replaced with a B-50D for the later test flights in the program. The program would have to continue on with only a single airframe. That airframe, 6674, with its XLR-25 rocket engine finally installed, arrived at Edwards Air Force Base in July of 1953 to continue the test program. On August 5th of 1954, over a year after its arrival at Edwards, That particular aircraft made its first glide flight with National Advisory Council on Aeronautics pilot Pete Everest at the controls. The aircraft sustained significant damage on landing and eventually had to be returned to Bell Aircraft in New York for repair. Several of the early X-2 flights ended in landing damage. A high center of gravity in the landing configuration was the likely culprit, and there was an engineer on the program named Stanley Smith, who was a prominent sailplane pilot of the time. He proposed shortening the skid strut assembly, and the problem disappeared on any future flights. The final flight of the X-2 program occurred on September 27, 1956, when Milburn Mel Apt became the first person to reach Mach 3. Unfortunately, following a sharp control input, the aircraft entered a condition known as inertia coupling. The X-2 tumbled out of control, and although Apt was able to separate the escape capsule from the rest of the aircraft, he was unable to pull himself free of the escape capsule. He died when the escape capsule struck the desert floor. Despite his death, serious consideration was given to repairing the aircraft following that crash. The aircraft had landed in remarkably intact condition, but eventually, given the number of other research aircraft in development at the time, this idea was eventually put to rest. Despite Apt's death and the loss of both aircraft, the X-2 program generated a fair amount of valuable data over the 20-flight test program. The X-2 reached a maximum altitude of 120,000 feet on Flight 19 and a maximum speed of 2,094 miles per hour, or Mach 3.196 on Flight 20. Perhaps the greatest contribution of the X-2 program was the development of high-temperature alloys for aircraft manufacturing. We've been able to uncover footage on most of the flights in the X-2 program. As you explore the remainder of this DVD package, each segment of flight footage will have a brief introduction of the highlights of that particular flight.